Okay, 9.2 is about special right triangles. So we're going to find the side lengths in special right triangles. So these special right triangles, there's two of them, and we'll talk about them each in their own aspect here. So a 45, 45, 90 degree triangle is an isosceles triangle that can be formed by cutting a square in half diagonally. So you can see that in the picture there. If you cut it in half, you're cutting each of those 90 degree angles in half, creating a 45, 45, and 90 degree triangle. So it says in a 45, 45, 90 degree triangle, the hypotenuse is, then I want you to add root 2 times as long as each leg. Okay, so you can kind of see this here in this picture, but first I want you to write 45, 45, 90 like this. Okay, so now if I look at this picture over here, so across from this 45 degree angle opens up to make this side, so that goes with X. Okay, then across from this 45 degree angle, you again see X. Well, that makes sense because if they're the same degrees, they should be the same side length too. Okay, then across from the 90, you have X root 2. Okay, so let's keep that in mind. So now we're gonna use that, and I would say like memorize that 100%, right? We're gonna write it over and over and over again through this lesson and the rest of the chapter. Okay, so example 1, finding side lengths in 45, 45 degree triangles. Find the value of X, write your answer in simplest form. Okay, so I know that this is a 45 degree angle, so this one has to be 45 too. So I'm gonna write 45, 45, 90, X, X, X root 2. Now, I'm gonna look at this picture and I'm gonna have it help me solve for the X that is in the picture. Now, don't get confused. This X that I wrote here is not this X, okay? It's not related, okay? I'm just using this to help me set up the problem. Later on, we'll go back and figure out what we're solving for and what it is, okay? So, I know the side length 8 is across from a 45 degree angle, okay? So that means that everywhere where I see a 45, right? That means that this X is 8. So that means that this X is 8. Okay, well, if this X down here is 8, X root 2 is just 8 root 2. Okay, now go back to your picture since we have all that filled out. What is the variable in the picture? Okay, well, it's X and it is across from the 90 degree angle. Okay, well, what did I say my answer was for 90? I said that it's 8 root 2. So in this picture, X is equal to 8 root 2. And that is your final answer. Okay, so same thing here, 45, 45, 90. And the reason why we know this is a 45, 45, 90 is because both of these are X, which means that they have to have the same angle measure, and that's the only choice is 45. Okay, so again, then we write X, X, X root 2. I know 5 root 2 is across from the 90 degree angle. So underneath 90, I write 5 root 2. Okay, and then I ask myself, okay, does that look like X root 2? Does it have a root 2 on it? And the answer is yes. So then I have to pick out just what X is, okay? And just X would be that 5. So that means that X is 5 and X is 5 here. So then in the picture, X is equal to 5 as well. Okay, we're going to see some different types of problems like that in just a minute, but we're going to go on and learn about the other triangle first. Okay, so first I want to move on to our notes to see the 30, 60, 90 triangle, okay, and this theorem 9.5. Okay, so it says in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is root 3 times as long as the shorter leg. Okay, so what that's telling me then, I have a 30, 60, 90 triangle now. Okay, across from 30 is X. Across from 60 is X root 3. And across from 90 is 2X. Okay, and you can see that over here in this picture as well. Okay, so example 2, find the values of x and y and write your answer in simplest form. So we are going to write out our angles first, 30, 60, 90. Write out your ratio, x root 3, and 2x. Okay, then stop and ask yourself, what do I know? Okay, well, I know that across from 60 is 9. Okay, so that means that under 60, I need to write 9. Okay, so now I'm going to come over here. Okay, before I guess I should explain why. I'm going to go over to the side. So if I'm looking at x root 3 and 9, 9 doesn't have a root 3 attached to it. It's not 9 root 3, it's just 9. Okay, so over here, in order to be able to solve for x, I'm going to have to do a little bit extra work. So x root 3 equals 9. Well, x and root 3 are being multiplied together right now. So I need to divide both sides by root 3. So x equals 9 over root 3. Okay, now I can't stop there because I can't have a square root in the denominator of my fraction. So I'm going to do something called rationalizing the denominator. And by doing that, we just take the top and bottom and we multiply by that square root. Okay, so I multiply by the square root of 3. Okay, so that would give me 9 root 3. The square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is just 3. Okay, so you basically get what's underneath your square root out. So 9 root 3 over 3. Okay, but then wait a second. 9 is divisible by 3. So this actually comes out to be 3 root 3. Okay, so x itself is equal to 3 root 3. So over here where I see x, I write 3 root 3. Now, once I know x, I can find 2x by multiplying by 2, okay? So I only need to multiply the number that is out front of the square root, so I only need to multiply 3 by 2, so it becomes 6 root 3, okay? So now go to your picture, and let's figure out what we're trying to find. So x is across from 30, so x equals whatever my answer for 30 was, so 3 root 3. Y is across from the 90-degree angle, so my answer for 90 was 6 root 3. And there's your final answers. Okay. All right, the road sign is shaped like an equilateral triangle. Estimate the area of the sign by finding the area of the equilateral triangle. Okay, so here, equilateral triangles, we know all have a corner, or the angles are all 60 degrees. So this one is 60, this is 60, and this one is 60, okay? An area I know is, for a triangle, is 1/2 base times height. Okay, so I know its base is 36, so area equals 1/2 36 times 90 to find the height. So if I take the height and I drop this, okay, there's my 90-degree angle, okay, up at the top here. You might not be able to see it since it's so dark. At the top is my 90-degree angle, so it's cutting this 60-degree angle in half. So this is now 30. So I have a 30, 60, 90. I'm going to redraw it out here to the side. So 30 is at the top, 60 is over here to the side. And I just cut that 36 in half to be 18, okay? And I want to find the height of my triangle is the whole purpose of doing this. So I want to find x. Okay, so I'm going to do a 30, 60, 90, which is x root 3, 2x. Okay, across from 30 is 18, so x is 18 over here. So across from 60 is 18 root 3, and that is actually what I'm looking for, okay? But I don't really know what 18 root 3 means in terms of a stop sign and height, okay? So 18 times root 3 is 31.17.
I didn't get that.
Oops, sorry.
Could you try again?
So then I'm going to multiply all of that together. So half of 36 is 18. 18 times 31.17 is 561.18 inches in its area, so it should be inches squared. Okay. All right, last example here. A tipping platform is a ramp used to unload trucks. How high is the end of an 80-foot ramp when the tipping angle is 30 degrees and then 45 degrees, okay? So whenever it is 30 degrees, so if this was 30, we have a 30, 60, 90, x root 3, 2x. Okay, so I want to know the height of the ramp. So that would be x over here. And we know that this is 80 feet up here. Okay, so across from the 90 is 80. So to be able to find across from the 30, I just need to take 80 divided by 2, and that would be 40. So x is 40 at a 30-degree angle is one answer. Okay, then I'm going to change this now to be a 45. So I have x root 2 for a 45, 45, 90. And I know across from the 90 is 80. Okay, so x root 2 equals 80. Or x is 80 divided by the square root of 2, because I can use real numbers here, or decimals since it's a real life situation. 56.7 would just be x then. So 56.7. So in this case, x is approximately equal to 56.7 at 45 degrees. And I guess they should, these are measured in feet. Okay. All right, we will do more examples in class over this, but I want you to go ahead and have these notes done and thinking about it before you get here, and we will do more examples and see lots of different ways that these problems look together. So there you go.